Hello, welcome to Grant Math.
We are learning about comparing or differentiating, which means finding the difference, between linear, exponential, and quadratic functions, which is also another way of saying graphs. So here we go. One way to do this is to just kind of talk about the basics. So the basics are, what do we know about something that's linear? A linear graph. A line. Isaiah, what else? Y equals mx. Whoa. Equals mx plus b. So something like y equals 1/2 x minus 5. Something. Whatever. That's good enough. Okay, now about exponential. So the ones we just were doing, within the past 5 to 6 days. Alan.
It's a J.
J. Or what if it's going the other way? What shape is that?
L.
Kind of an L looking. Diego, what?
I forgot what I was going to say. Darn it, never mind.
That's okay. Anybody else?
Oh, wait.
It's like a times b to the x.
Oh, y equals a times b to the x. My exponent is always x. There's never a number that's the exponent. The exponent is always x. Okay, now what about quadratic? What do we know? What have we learned about that?
It's a parabola.
Parabola.
It's y equals ax squared plus bx plus c.
Y equals ax squared plus bx plus c. So the exponent is a 2. And it could be more, it could be longer, or shorter, just like x squared. Like here's a short one. X squared. Y equals 7. And then what about something like this? X minus h squared plus k. Like with these being numbers, So that's vertex form though. But it's still a parabola. All right, number 1. So just by looking at it, let's talk about what they are. Number 1, what is it? Linear. Okay. Fun, hot pink. Number 2. Yeah, quadratic. It's like sideways, but still. It's a parabola. Last. Ooh, it's neither, guys. We haven't learned one like that before. I'll tell you what it is, though, but... So this is called y equals x to the 3rd power. But, again, it's not on our agenda today, so... Neither. Put neither. Number 4, what is it? Good. Number 5 is what? Parabola, which means quadratic. Number 6.
Neither.
Good. That would be one to the 3rd power because it's got 3 changes, but again, not important right now. Oh. 7, what'd you say? Okay. 8.
Quadratic.
Okay, it is, so, let me tell you what it is, though. It's absolute value. You guys, did you guys even know that? Just made you like, ooh. Like you're so enlightened by that information. For your viewers. You guys are my viewers. Nobody else watches this. Every Friday. All right, here we go. We are now going to talk about comparing tables of values. One big deal with tables of values is that my x's are always going to be just whatever. And they're always just pick the same type of things, like -2, -1, 0, 1, 2. Like those are the x's that will stick for no matter what shape your graph turns out to be. It's the y's that really create the defining changes. So linear. So when I have a linear graph, which is just, kind of like y equals mx plus b, the x's are always going to be the same. So let's talk about the y's. The y's will have a pattern. Maybe it'll grow or increase by the same number. Like every time we go to a new ordered pair, the y increases by 5, or by 2s, or decreases by 1, something like that. And so it could grow the same, and it also could decrease by the same number. So that's linear. That's the main thing. So it's going to be a pattern, but just basic plain old numbers. Nothing crazy big, crazy small. Exponential. The y's. Remember how exponential graphs get really, really close to the horizontal asymptote and they never touch? Which means they get like really small, like 0.5, 0.25, 0.01, like these numbers are just super small. So my y's are small and they decrease like quick. So all of a sudden you've got like a 1 and then it's a half and then it's a small fraction, 1/16. Or the numbers get really big and they increase huge, like to where we can't even graph them, like 48 or 25. So an exponential growth means like the growth is growing by this exponent. So I could say like a 3 and then a 9 and then a 27 and then an 81. That's growing by the third powers. So either really small decreases like fractions or huge increases where you can't even graph it because the numbers are so big. Because this line is just going up, up, up forever, and it's getting super close down here to 0. Quadratic. Quadratic is the parabolas, right? So we're going to have pairs of numbers. And what I mean by pairs of numbers is things like, let me just make up one. So please notice how these numbers are pairs. Like they repeat again. And we talked about this because it's a U-shaped. These numbers, this -1 in my y, I got this cool new little focus thing. Watch this, guys. The -1s here by the y's,
Like a laser.
I know, are the same. The zeros are the same. And I have more choices. Oh, you'll like this one. It's like a lightsaber.
Oh.
It's a purple lightsaber.
Mace Windu.
But I don't know why it made that sound. Oh. It's called Star Wars. This is good video material. I like this. Okay. So the point is that it's always going to be pairs, zeros, or like this. There, then the edge of the. All right. On this program, it does. So you have to be able to see some sort of pattern where the numbers repeat. Okay, we're done. The numbers are going to repeat. Like there's going to be 2 of the same number. Only in the y section, though. So now let's talk about it. Let's put this into practice. This table of values looks different. It's horizontal, but that's no big deal. Okay, number 9. Look at the y's. That's what we're focusing on. It's always going to be about the y's. So the y's here. What about them? Is this going to be, what is it? Like, you can kind of say, oh, look, -2, -2, -2, -2. We talked about finding slope by making little, like, arrows like this, right? Is it linear? Is it exponential? Is it quadratic? Linear. Number 10. Howard's, look at these crazy 227s. I mean, look at these numbers. 54, exponential. $11. What's happening with the numbers? Up. It's a pattern, so it's a quadratic parabola. 12.
No, it's
I don't know that it's neither, but it's not quadratic because they'd have to be the same. Like they're not the same. Linear. You know what I could do if I was super unsure? Draw a little graph over here and just make my little dots. Doot, 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 doot.
That's crazy. Like dots. No line.
It's linear because the numbers do. Here's the way I know. Here's the way I knew when I did this and I worked it out. This added 5. Here I added 3. Here I added 1. Here I added 1. Here I added 3. Here I added 5. See how there's like a pattern? And then I ended up graphing them and it actually turned out to be a straight line. Okay? The straight line looks like this. It's like this. Okay? Ooh, 13. Okay, one thought. I need more input. Okay, it is exponential. $14, what is it? Yeah, and it's changing by fives. Yeah. Good. Third way. The third way that I'm going to teach you to differentiate between the types of equations is actually just to look at the formula. So again, what is the formula for linear equations? What is the equation for exponential? Yes. Y equals yes. Well, I heard her starting to say it, so I just, of course. No problem, Sabrina. Just kidding. Just kidding. Does that make you mad? Does it make you mad? All right. Just by looking. 15, what is it?
Quadratic.
Just by looking. 16, this is a tough one.
Exponential.
Exponential means that there's an x in the quadratic only has squareds.
Linear.
There's always that fourth choice. Neither. You are very welcome to test it out and graph it on the side if you're interested to know what that would look like. 17.
30.
17, what is it? Why are you saying 30? Why?
17, 30. It's a song.
17.
Okay. I don't know the song, sorry. What'd you say 17 was?
38.
My goodness. So there's 17 and 18 already done for you. Number 19. There's no squared though on. It's linear. Why? This is y equals mx plus b. And 20, last one.
Exponential.
Well, it's actually not the last one, but on my slide, it's the last one. Okay, that's good. All right, these are the last ones to finish off. 21. It's got an exponent of 2, which is a giveaway. Quadratic. 22. And, 23.
Quadratic.
Well, it has a third power and a fourth power, though. Neither. Try graphing that one. I know you thought. Don't worry, you don't have to. It wouldn't be very much fun, would it?
Not really.
So now, this is what your homework problems look like. And with these, if you're unsure, if something's like, oh, it could be these two, I don't know for certain, you could do something like check your y's and see how it increases or changes and see if it increases by the same thing. Because many a time when it increases by the same thing, that's linear. So for example, number 1 is linear, and I was able to show my work or check it by putting that I was increasing by 4. I was working backwards, but